right, here's everybody's favorite. Time constants. What? Feel like tomorrow. Okay, inductance and capacitance in a DC circuit. This is where we are talking about what happens between the instant you flip the switch on and the fit time constant. Okay, the instant you flip the switch on and the fit time constant. We're trying to find out a voltage or current on a curve. Everybody remembers the curves, right? Okay. Bottom line, an inductor stores what? A current, and a capacitor stores voltage. Okay. First, you've got to get a time constant. You've got to get a time constant for each loop. Unless we ask you, hey, what's happening at the fit time constant? Then you know what happens at the fit time constant. It's either 0 or max. What's happening at the fourth time constant? There's really no need to calculate your time constant. Just take the natural number e, raise it to the -4, or whatever time constant we're giving you, right? If you want to do the math, knock yourselves out. Okay. So, you're likely going to see something like this tomorrow. After 4.8 milliseconds in switch position 1, the switch is flipped to position 2. How long does it take to get voltage of R2 to 2 volts? Whatever. Okay, that's what the question's going to look like. Know how to do that. Know how to take, what are you going to take across? Current. And calculate what the voltage would be of R2 at some time, or the current of R2. Okay? All right. And here's our curves. And the 1 minus, right? So that's the rise equation. And without the 1 minus is the decay. Right? Everything in the second loop, what happens? Decay, everything. And everybody see that L1 and R2 are in parallel, right? So the voltage of L1 equals the voltage of R2, right? Okay. So one of them is decaying, the other one has to be decaying. Okay. It's a loop, they have to equal each other. All right, capacitance. Capacitance in a DC circuit, we'll ask you the same thing. After so many microseconds in position 1, the switch has moved to position 2. What is the current of R2 after so many microseconds? Time constant here, figure out what happens at that time. Bring what over? Voltage over. New time constant, find out what happens at that time. Okay, so what's happening to voltage at C1 in position 1? It's charging, so it's doing what? It's rising, and then everything in position 2 is decaying.